Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Space Telescope has done it again, another discovery that seems to break the rules of how we think the universe works. At this point, are we even surprised? Over the past couple of years, JWST has uncovered cosmic wonders that challenge our understanding of cosmology, but this one is on a whole new level. Meet ZFUDS 7329, a galaxy that's 11.5 billion years old, which on its own doesn't sound too crazy. After all, the universe is 13.8 billion years old, so there was plenty of time for it to form. But here's where things get weird. This galaxy is absolutely massive, packed with more stars than the Milky Way. And according to everything we know, a galaxy that old shouldn't be this big. So astronomers turned to JWST for a deeper look, and that's when the real mystery unfolded. Spectral analysis showed that the stars in ZFUDS 7329 formed 1.5 billion years earlier, which means this gigantic galaxy was already in place just 800 million years after the Big Bang. That's a problem. While astronomers aren't exactly sure when the first stars and galaxies started forming, the standard model suggests this process took a bit more time. So, what does this mean? Is our timeline of the early universe off? Are we missing a key piece of the puzzle? One thing is certain, JWST isn't just helping us see deeper into the cosmos. It's forcing us to rewrite what we thought we knew. After the Big Bang, astronomers believe that the first galaxies didn't just appear out of nowhere. They formed around dense pockets of dark matter known as dark matter halos. These halos, with their intense gravitational pull, acted like cosmic magnets, drawing in gas and dust left over from the Big Bang. Normally, this material would have been too hot to clump together, but thanks to dark matter's influence, it started forming the first stars. Over the next billion or 2 years, these clusters of young stars evolved into dwarf galaxies, which later collided and merged to create the large galaxies we see today. Now let's get back to ZFUDS 7329, a galaxy that, like all early galaxies, should have depended on dark matter to take shape. But here's the problem: at that point in the universe's timeline, those critical dark matter halos wouldn't have had enough time to fully develop. And the mystery doesn't stop there. After an intense burst of star formation, this galaxy suddenly went silent. Its star-making activity came to an abrupt halt. But why? The universe follows patterns. Whether on a microscopic scale or a cosmic one, everything moves according to certain laws. Things don't just appear out of nowhere, nor do they vanish without a trace. The first law of thermodynamics tells us that energy can't be created or destroyed, only transformed. Planets emerge from stars, stars form within galaxies, and even galaxies themselves merge to create larger structures. A dying star can collapse into a black hole, atoms combine to form molecules, and life itself continues through reproduction. In a way, the entire universe is one grand cycle of transformation, matter and energy shifting from one form to another. But ZFUDS 7329? It seems to be defying the very process that shapes everything around us. And that's what makes this discovery so intriguing. Now, here's where things get really interesting. Researchers from the University of Copenhagen and the Tokyo Institute of Technology have proposed a bold new idea. Our universe might be absorbing smaller baby universes, fueling its continued expansion, kind of like how galaxies merge to form bigger ones or how black holes collide to become supermassive. At its core, the idea suggests that our universe keeps colliding with and swallowing up smaller universes, causing it to grow larger over time. This could provide a surprisingly intuitive explanation for dark energy, the mysterious force driving cosmic expansion. In fact, the researchers argue that this model might actually fit the data better than the standard cosmological model we currently use. The concept of multiple universes isn't new, but this study takes it a step further by using a mathematical framework to explore what happens when universes interact. Their calculations reveal that these cosmic mergers could not only explain why the universe is expanding, but also why it's expanding at the rate we observe today. This theory doesn't just propose a wild new idea, it also seems to solve several long-standing cosmological mysteries. One of the biggest puzzles in modern cosmology is cosmic inflation, the ultra-rapid expansion of the universe that supposedly occurred just milliseconds after the Big Bang. While the standard model acknowledges this expansion, it doesn't fully explain why it happened. The new study, however, offers a fascinating possibility. What if our young universe was absorbed by a much larger parent universe? This collision could have triggered the super rapid inflation, and from that point onward, our universe continued merging with other baby universes, fueling its growth. Then there's the mystery of stars that seem older than the universe itself, like Methuselah, a star that, based on current measurements, appears to predate the Big Bang. While this isn't something the researchers directly addressed, it's an intriguing possibility. If our universe is the result of multiverse mergers, then it could explain how certain celestial objects seem to have existed before our universe's official timeline even began. Another major anomaly is the discovery of galaxies that formed much earlier than expected. Before the launch of the James Webb Space Telescope, scientists believed that it would take nearly 1 billion years for the first galaxies to form after the Big Bang. But recent observations, first from Hubble and now from Webb, have shattered that assumption. We've detected galaxies that existed just 350 million years after the Big Bang, as well as black holes that formed just 400 million years after. These discoveries don't fit neatly into the standard model, but if our universe has been growing by absorbing other universes, that might offer an explanation for why galaxies and black holes appeared so quickly. And finally, there's the question of whether our universe is actually younger than we think. In a recent study, scientists led by Professor Glowy examined galaxy groups using data from the Sloan Digital Sky Survey, one of the most detailed astronomical surveys ever conducted. Their research focused on how satellite galaxies move around massive galaxy groups, but with a unique twist. They paid special attention to pairs of satellite galaxies positioned on opposite sides of these massive clusters. What they found could challenge our current understanding of cosmic age and structure. If these ideas hold up, they could completely reshape how we see the universe, not as an isolated entity, but as part of a much larger, interconnected multiversal landscape. The implications are mind-blowing. Scientists analyzed the movement of galaxy pairs, similar to studying traffic patterns in a city, and noticed something unusual. Some pairs were moving in a way that suggested they had only recently joined larger galaxy groups. This contradicts computer simulations, which predicted a different pattern. The significant mismatch between observations and simulations suggests that these massive galaxy groups might be younger than we previously thought. If true, this could mean that large cosmic structures across the universe are also younger than our current models estimate. Since the age of galaxy groups is closely linked to the overall age of the universe, this finding challenges previous calculations based on data from the Planck mission's cosmic microwave background observations. Lead scientist Queen Gu, in a study published in Nature Astronomy, emphasized the importance of revisiting our cosmic timeline, hinting at the possibility that the universe itself might be younger than we've long believed. While the universe merger theory offers a potential solution to many of these cosmic puzzles, it still needs strong observational evidence to back it up. Ongoing experiments studying the cosmic microwave background, along with new observations from the Euclid and James Webb Space Telescopes, could provide crucial insights. As more data comes in, time will tell which theory truly explains the nature of our universe. And that's it. Thanks for exploring the cosmos with Spaceverse. The universe might be younger than we thought, galaxies are forming way too fast, and maybe, just maybe, we're merging with baby universes. As the James Webb Space Telescope and future missions unravel more mysteries, one thing's for sure, the story of our universe is far from complete. Subscribe for more mind-bending discoveries, and as always, stay curious, stay cosmic.